Question number 4, a program is being written to control the operation of a portable music player. One part of the program controls the output volume. The player has two buttons, one to increase the volume and one to decrease the volume. Rocker buttons. Whenever a button is pressed, a procedure button is called with a parameter value representing the button as follows: volume increase, parameter value 10, volume decrease, parameter value 20. Okay. For example, pressing the volume increase button 3 times followed by pressing the volume decrease button once would result in this: call button with 10, call button with 10, call button with 10, call button with 20. All right, volume level decreased by 1. So parameter value 10 will tell that we need to increase the sound. Parameter value 20 will tell that we decrease the sound. We want to decrease the sound. Okay, so take it like 1 and 2. 1 increases, 2 decreases. Or 10 and 20, 0 or 1, whatever. They have made it different so that you could be actually thinking more about it. Okay, so the program makes use of two global variables of type integer, volume level, the current volume setting. This must be in the range 0 to 49. Okay, so what basically happens when you call this subroutine with 10, the volume will be increased by 1. If you call this button with 20 as parameter argument, the volume will decrease by 1, but volume has to be between 0 and 49. So if it is 49, you cannot further increase it. Similarly, if it is 0, you cannot further decrease it. So maximum volume is 49 and least volume is 0. Maximum volume, a volume that can be set to limit the maximum value of volume level in order to protect the user's hearing. A value in the range 1 to 49 indicates the volume level. A value of 0 indicates that no volume has been set. The procedure button will modify the value of volume level depending on which button has been pressed and whether the maximum value has been set. So what they want? All right, so they want us to write the procedure button. Procedure button it accept volume as integer. Remember, this volume might be either 10 to increase by 1 or 20 to decrease by 1. Nothing else. Okay. So now we are going to check if volume is equal to 10, it means that we have to increase the sound. Then we have got this maximum volume. Should not be changed within the procedure. So maximum volume will always be 49. Then if then means what? We have to increase the sound. If, what is the other one? Volume level. If volume level, okay. If vol level is less than 49, then vol level is equal to vol level plus 1. Okay. If volume is equal to 10, then okay. If else if it is not 10, then it is 20 definitely. then if volume level is greater than 0, then volume level is equal to volume level minus 1. And if we have to protect it so that it does not go beyond 49. So if they want us to increase volume by 1, or they want us to decrease volume by 1. Okay, so that's it, and procedure. You don't need anything else. Let's read it again. For example, pressing the volume button 3 times, followed by pressing the volume button, decrease button 1 time, would result in this case. What is volume greater than 10? This is the value, that is 10 or 20. The program makes use of two global variables, volume level. The current volume setting must be in range 0 to 49, maximum volume value that can be set limit to maximum volume in order to protect the user's hearing range. Okay. So what you can do, instead of 49, you should put maximum volume. Okay. So that's it. This is the correct program. So in the volume, you are actually receiving either 10, which is +1, or 20, which is -1. So if you receive 10, it means that you have to increase the volume, but maximum volume, if it is less than maximum volume, then only you can increase volume by 1. And otherwise, if the volume is greater than 0, then only then you can reduce the volume by 1. The second choice में volume is equal to 20 नहीं, because there are just two possibilities here. Agar if it is not 10, then it is 20. If it is 20, then it is not 10. Okay, that is why. What do you say? The volume greater than 0, which you used in the program, why it is needed to be used? There is no purpose. There is purpose, because you have to keep the volume between 0 and 49. If it is 0 and you reduce it, it will go below 0, which is -1. That is why it is necessary. You have to keep it in between 0 and 49. All right. If it is greater than 0, only then you can reduce it. So you cannot reduce below 0. Let's say if the volume is already 0, in that case, if you're reducing it further, we'll make it -1. That is why there is purpose of it. Okay? Now part B. The procedure button is to be tested using black box testing. Remember black box testing? Black box testing does not concern all line of the codes. Rather, black box testing is just concerned that you give some input to the program and you check the output. You are not concerned about whatever that is happening inside. So fill in the gaps below to define 3 results that could be carried out. Test 1, volume level is changed. Parameter value is 10. Maximum value is 49. Maximum value is 49. Volume level value before call to button is 48. Volume level expected after the call is 49. Okay. Test 2. Parameter value 10. Maximum volume is 34. Volume level before the call would be 34. Volume expected after the call will remain 34. So if the maximum volume is 34, volume level, the value before the button, let's say If it is not 34, let's say if it is 24, it will become 25. But if it is 34, it will remain 34 because that is the maximum volume that you have. Remember, this 10 is not 10. This 10 means that you have to increase the volume by 1. Okay. So volume level before the button press was 0. Maximum volume is 40. Volume level expected after the call to button. So we have checked it for 10. So let's check it for 20. So 20 means what? Minus 1. Since it is already 0, it will remain 0. Okay, so this is the test plan sort thing, which is easy basically. And it may have very varying results. You might fill it other way, I might fill it other way. Remember that we have got, let's say, 0 to 49 limit. So this is extreme. Whatever that is in between is normal. If it is below 0 or greater than 49, so abnormal. So you can check it for all, but you see abnormal values, whether it goes below 0 or greater than 49, will be actually in check. So system won't let the volume go below 0 or greater than 49. All right. Part C. Part C says the testing stage is part of the program development life cycle, right? The program for the music player has been completed. The program does not contain any syntax error, but testing could reveal further error. Identify and describe one type of further error. Further error might be a logical error, might be an error that crashes it, a runtime error. Okay, so let's write logic error. So what is the description? Uh, at execution, program behaves unexpectedly. Okay, so it is not behaving as we have thought of. Stub testing is a technique often used in development of modular program. Describe this technique. What is a stub testing? Let's say you are to develop 10 subroutines to complete the program, but the thing is that out of those 10, 6 are simpler, but 4 are actually complex. So simpler ones are completed by their respective programmers and turned up to the program manager or to project manager. But those 4 which were complex will be completed later because of their complexity and length, and they will be turned up later. So project manager would definitely not be wanting to wait for those 4 to be completed to check other 6. So for the checking of the program, it is exactly required that all of the subroutines are completed. So what project manager would do, he will create 4 fake subroutines in place of those which are being built and are complex at the moment. And those 4 fake subroutine will fill in the place for those 4 yet not completed subroutines. So those 4 subroutines which are not completed and their fake versions or empty subroutines are made are called stubs. So stubs are made to check those parts of the program which are completed. Okay, so stubs are empty subroutines like procedures, maybe outputting a single prompt, or functions returning a fake value. Stubs are made to complete program structure so that completed subroutines could be checked for the integrity. Okay. So stubs are dummy modules. Okay. So simple dummy modules to replace actual modules. When actual modules are completed, these dummies are taken out and actuals are substituted for that. All right. Now, the module header for three modules in a program are defined in pseudocode as follows. Procedure lookup P4 as integer, byref M4 as a string. Okay. Function update T4 as integer returns integer. Okay. Function validate S2 integer P3 string returns boolean. Okay. A fourth module renew calls the three modules in the following sequence: validate, lookup, एक सेकंड होल्ड कीजिएगा. Okay. The module header for three modules in a program are defined in pseudocode as follows. Procedure lookup, function update, function validate. A fourth module renew calls the three modules in the following sequence: validate, lookup, and update. Draw a structure chart to show the relationship between the four modules and parameters passed between them. Okay. Now, you say this is renew. Renew is basically calling. Okay. So first validate is being called. Okay, when validate is being called, it is being sent S2 and P3. And then we have validate is called, then lookup. Lookup is being called and it is being sent P4 and then by ref M4. So this is M4. And then we call update. Update is being called with what? T4. And it returns an integer. And function validate or returns a boolean. See, so it returns a boolean. So it is, if it is by ref, then we have to use this particular shape. These are called data couples and this is flag. Question number 6. A text file student list contains a list of information about the students in a school. Each line of the file contains a reference name and date of birth for one student. All the information is held as strings and separated by asterisk. As of now, you would have this idea, a firm idea in your mind. Then we have got two ways saving a record in the text file. Either you save every field which is turned into text in one line of the code, and then basically, if let's say if you have got three fields per record, you would have 3 lines in the text file per record. Otherwise, what you can do, You can concatenate all three fields together with special characters such as asterisk here. An example is this. So reference, then name, and then date of birth. The reference string may be 5 or 8 characters in length and is unique for each student, and it is made up of alphabetic and numeric characters only. Alphabetic and numeric characters. A global 1D array levers contain the reference of all students who have recently left the school. The array consists of 500 elements of the data type string. Unused element contains empty string null. A program is to be written to produce a text file updated list.txt containing information of only for students who are still attending the school. The program is to be implemented as several modules. The outline and description of three of these are as follows. Process student list, read each line from the file student list, check whether the reference appears in the array using search levers. If reference does not appear, then write the line to the file updated list. Return the number of lines not copied. Search levers, search for a given reference in the array levers. If the reference is found, then return true, otherwise return false. Take two parameters, the name of, this is count times. Take two parameters, the name of an array and a string, count the number of elements that are the same as the string, return the count value. Take two parameters, the name of the array and the string, count the number of elements that are the same as the string, return count value. Okay. Now, search levers. We have to write search levers. So what search lever does, searches for the given reference in the array levers. If the reference is found, then return true, otherwise return false. Okay. So what exactly do we have in this array? Let's first find it out. A global 1D array levers contains the references of all students who have recently left the school. The array contains 500 elements of type string. Okay, so this reference is basically in the file and in the array, in the file with the record, but in the array there are just references. Okay, so we have to actually have this program search for a given reference in the array levers. So we will be using this reference as the parameter. If the reference is found, then return true, otherwise return false. Okay. All right. Function search levers. It accepts reference as a string and returns Boolean. Returns Boolean. So we have to search through the array. So we have to declare an index as integer. And we have to have a flag found as Boolean. So we initialize it to 0 and we initialize it to false. We will use while to avoid any exit for thing. While I is less than 500 and found is equal to false. Okay. if levers, this is the name of array which we have to actually search for. If levers is equal to reference, then found is equal to true, else I is equal to I plus 1. There is no need to put I is equal to I plus 1 in else. You can end if here and then you can write I is equal to I plus 1 anyway. And then end while. And then if reference is found, return true, otherwise return false. Okay, so return reference and function. So I tell you what, since you initialize the found at false, let's say if it is found, uh, then if it is found, then found would have already become true. So return, not reference, return found, sorry. Okay, now, so if it is not found, found will remain false and it will be returned. If it is found, then found will be true and it will return found anyway. So this is the code that you have to write.